Hi, ladies and gentlemen. This is Mr. Green. This is another in my series of lessons on Algebra 1. This is over Unit 2, and we're looking at the one of the lessons there. It's dealing with sets. Now, just as an overall picture, what you need to understand is that a set is a defined collection of numbers or objects, okay? And what we're looking at is we're looking at different operations that are defined in a set. It helps us understand that how we can communicate better, okay? Once we start talking about sets and what operations we can do in those sets, it really helps us understand how things work just a little bit better, okay? So we'll talk about that more at a later date, but for right now, just realize we're just talking about collections. Any number set out there is just a collection of numbers. As you can see, this collection of numbers is 1, 2, 3, 4, and 5. That is a set. It's not a named set, but it is just a set of numbers. If I wanted to give it a name, I could say that it's equal to the capital letter A. And then I could call this set the set A. Okay? But for right now, it is just a set of numbers. Now, is this set an important set? Maybe. It might be part of a particular situation. I have no idea. But if you look at this set, is it a closed set? No. Closed would mean that if I added 1 plus 5, it would still be in the set. Well, 1 plus 5 is 6. 6 is not in my set. Therefore, this is not a closed set. And so there's not a lot of operations that we can do in this set of numbers and maintain ourselves in this set. But that's what we're going to be looking at as we go along. Some of the sets that you might be familiar with, we have the natural numbers. This is one that is named, okay? Natural numbers, N. Okay? That would be all the numbers 0, 1, 2, 3, 4, etc., etc. Okay? These natural numbers are closed under addition. So I can add 1 plus 2 and 3 will be in the set. Or I can add 1 plus 3 and 4 will be in the set. It is all the natural numbers. It's closed under addition. Is it closed under subtraction? No. 3 minus 2 is 1. Well, that one's there. But 3 minus 4 is negative 1. That one's not there. So it is not closed under subtraction. See the difference between those two? Good. So when we go on, that's when we had to invent another set of numbers. These integers, z. These are the ones that are closed under addition and subtraction because we've got the negative numbers in here. So I now can say 3 minus 4 and get negative 1 and it will be in the set. That is why we call this one closed under addition and subtraction. Okay? One of the other sets that you might have heard about is the rational numbers. Now they use the letter Q for this one. Okay? And the rational numbers are these fractional numbers that are in between the numbers. Basically, if you can express it as a fraction, then it will be a rational number. Okay? If it can't be expressed as a fraction, it's not a rational number. Fair enough? So, they say the rational set of numbers is closed under multiplication. It's closed under division. Because what you can do is you can do any multiplication and division and wind up with another rational number. So that's just where you have to recognize that's what rational numbers are. Then we start talking about the real. Now, this particular slide shows two different types of reals, but this is the one that's typically talked about. The real numbers are. Okay? Real number R is different from the rational numbers because we are going to include every number on the number line here. You said, well, aren't every number included up here in the rational numbers? No, only things that can be expressed as fractions. Things like the square root of 2 cannot be expressed as a fraction. Things like pi cannot be expressed as a fraction. Things like the constant e cannot be expressed as a fraction. They can only be expressed as a real number. They're somewhere in between all the rational numbers. Okay? So that's what we talk about the real numbers. And the real numbers are also closed under multiplication and division. So these are the different sets that exist out there that you might hear about at some point in time. Okay? And when we start talking about algebra and going further into mathematics, we'll start talking about these more and more and more. But I want to make certain you understand. When we start talking about sets, there are certain ones that are predefined and that certain information is known about them. Okay? Okay. Well, hopefully if you have any questions, you can bring those to wait a second. There is a couple more. There's one more slide here. One of the things we talk about when we start talking about sets is the concept of the intersection and the union. What does that mean? Well, when we talk about the union of two groups, two sets, like this set here, 1, 2, 3, and this set here, 3, 4, 5, we combine them together and we list all the items that are in both sets. That means we would list the 1, the 2, the 3, the 4, and the 5. They're in the sets, and so they are union together. They're added together. They are combined together. That is what the word union means. Okay? Now, if you take the intersection, intersection is where they overlap. So 1, 2, 3, and 3, 4, 5, the only place where they overlap is at 3. You might have seen this drawn as Venn diagrams. 1, 2, and 3, and 4 and 5, like this. The union would be everything that's inside of the circles here. The intersection would be the 3 that's here in the middle because it's in both sets that are there. That is one way that you can visualize what union and intersection mean. This is the intersection here, and the whole thing is the union. Okay? So, that's what we're talking about when we're talking about union and intersection. You will see those terms here in this lesson, and then you'll also see them as we go along in the algebra. Okay? Cool. Well, hopefully if you have any questions, you'll bring them to the Class Connect or you'll bring them to the tutoring sessions. Look forward to seeing you next time.